So 5.2 is over absolute value equations. So normal solving techniques, like solving for x, so we would like subtract if it was added, we would divide if it was multiplied, that kind of stuff. The only difference is that it's absolute value, and so there's another like layer to that, which kind of makes each problem like a double problem. It doesn't make it any more difficult, it just makes it more. Okay, so if we're talking about absolute value in general, like when I take the absolute value of 3, what do I get? 3. But when I take the absolute value of negative 3, what do I get? 3. So no matter what, it's positive, right? It's not that the sign switches so that if it's absolute value of 3, it'd be negative 3. It's not that. It's that no matter what's in the absolute value, it's always positive for the answer. Always positive. So if I take, if I have an answer where it's the absolute value of x equals 3, meaning what would I put in the absolute value to equal 3? If I plugged in a positive 3, I'd get an answer of 3. But if I plugged in a negative 3, I'd also get an answer of 3, right? If I took that x and plugged it in, no matter if it was positive or negative, my answer would be positive. Same thing with x. Because if so like let's say I was substituting in with this equation right here. If I did the absolute value of 3, I get 3, so x equals 3. But if I do the absolute value of negative 3, I also still get 3. So basically, absolute value has like 2 answers because it could be positive or it could be negative.
But I thought absolute value meant the distance from 0.
It does, but it's always positive.
So why is
It's not. X equals negative 3. But when I plug that into the absolute value of x, I'm always going to get a positive 3.
Like if you put the negative 5 into the absolute value, it's going to be positive 5. But negative 5 because it's in the absolute value.
Oh.
X is in the absolute
Yeah. So think of like before you take the absolute
But it
value.
could also be positive.
It could be positive 5 or negative 5. And so it's
negative?
basically it's saying like we could have 2 things to plug in for x. If we plug in a positive number, we're going to get a positive number. But if we plug in a negative number, we're also going to get a positive number.
So basically, if there was a number between like the absolute lines, it will be positive. But
Exactly.
If it's
It's negative.
If it's an x, it could be positive or negative.
So whenever it
Yes.
says x equals, you just put the negative in that number.
You put a positive and a negative one. Yes.
Okay.
Yes. Yes. So if I had x equals 5,
okay.
my x could be a positive 5, but it could also be a negative 5, right? If I have absolute value of 300, I could have a positive 300 or a negative 300 in absolute value. Because no matter whether I take the absolute value of 300 or the absolute value of negative 300, I'm still going to get a positive 300 as my answer, okay? So basically what that's going to show us is that when we're solving absolute value equations, we should always write 2 equations. Okay, 2 equations. We're going to be writing 1 equation for the positive and 1 equation for the negative. Okay, so that's where that basis comes from. So when we're doing these examples like 1, 2, and 3, we are going to solve each equation by splitting into 2 equations. One positive answer, one negative answer. Because that undoes the absolute value. So we're going to split the 2 equations, split into 2 equations, one that has a positive answer, one that has a negative answer, and that basically takes care of the fact that it's absolute value. But we will get 2 answers for all of our absolute value equations, okay? We're going to have two answers for number one. X equals, or absolute value of x minus 5 equals 7. So we're going to do one equation with a positive 7. So x minus 5 equals 7. Or we're going to do an equation with a negative 7. X minus 5 equals negative 7. So once we split into our two equations, we can drop the absolute value symbols. We don't need them anymore because having a positive 7 and a negative 7 undoes the absolute value. Okay, so now once we split and we do one positive and one negative, we just have two normal equations that we're solving. Okay? So if I'm solving two normal equations, how will I solve this first one? X minus 5 equals 7. Add 5. And so x equals what? 12? So there's one of my answers. And then over here, I also add 5. But now I'm adding 5 to a negative 7. So that changes things. So x is going to equal what? Negative 2. Those are both my answers. Basically saying if I take 12 and I plug it into x, I'll get 7. But if I take negative 2 and I plug it into x, I will also get 7. Yeah? So for number 2, do you see how there's something in front of my absolute value symbol? There's a 5 in front of it. So our first step is always going to be to isolate the absolute value bars first. So what that means is get rid of anything that's around the absolute value bars. So if I want to get rid of this 5 that's in front, it's 5 times the absolute value of 5x minus 10. So how would I get rid? Think about it being multiplication. How would I undo?
The dot and then 5 and then
Divide by 5. Oh, not negative. Divide by 5. So it's 5 times the absolute value. So we're going to divide by 5 on both sides.
Why don't you just
Because it's not parentheses. Yes. Because it's 5 times the absolute value of 5x minus 10. So to get rid of that 5, since it's being multiplied, we're going to divide it. And so we still have the absolute value of 5x minus 10 equals 45 divided by 5 is 9.
Wait.
Now that I'm here and my absolute value bars are completely isolated, they're all by itself, now I can make one positive and one negative. We do not want to start with the one positive and one negative with the 45, the equals 45. We want to make sure it's completely isolated first. So now I'm going to have 5x minus 10 equals 9. And 5x minus 10 equals negative 9.
Wait, why'd you get rid of the bars?
So once we split the equation, we get rid of the bars. Okay? So we isolate the bars, then we split to get rid of the bars. Making a positive 9 and a negative 9 takes into account the absolute value, so we don't need to continue using it when we solve.
Okay.
Yeah. So now we will solve like normal. So we will add 10. We will get 5x equals 19. Divide by 5. And so x equals 19 over 5. And we will just leave it like that. And then we will add 10. But this time we're adding 10 to a negative 9. So we will have 5x equals 1. So x equals 1 over 5. So once again, two answers, one for a positive 9, one for a negative 9. So number 3, we have a 2 in front of the absolute value bars. That 2 is being multiplied. And then we have a minus 9 after the absolute value bars, okay? we're always going to move things that are being added or subtracted first and then being multiplied or divided second. That's our PEMDAS backwards, okay? So I need to get rid of this 9 first. Since it's a minus 9, I'm going to add 9 to both sides. So I have 2 absolute value 4x plus 11 equals 4. Now I can get rid of the 2 by dividing. So I have absolute value 4x plus 11 equals 2.
So wait, dividing by the 2, does that just cancel out the 2? But then why wouldn't you divide 4x plus 11 by 2?
Because it's like it's in parentheses. It's like it's protected. We're just getting rid of the 2 in front. So now that we have the absolute value bars completely isolated, we're going to do one positive answer, one negative answer. So I have 4x plus 11 equals 2, and 4x plus 11 equals negative 2. So now I'm going to solve for x like normal. 2 minus 11 is what? Negative 9. And then I divide by 4. So I have x equals negative 9 over 4, and we can just leave it like that. And then same steps on the other side, but instead of subtracting from a positive 2, we're subtracting from a negative 2. So that's going to give me what? Negative 13. So x equals negative 13 over 4. Now, something important to note with absolute value is when I have an equation that I'm about to split, okay, so an equation before I split it into one positive and one negative. If you notice on numbers 1, 2, and 3, I had it equal 7, equal 9, equal 4. They were all positive, right? But if I have something that equals negative 4, then my answer is no solution.
Wait, just the number negative.
Well, anything negative.
Wait, what?
So
Anything negative.
if it's an absolute value equals a negative, but
There's no solution.
Wait, hold.
This is not possible with absolute value, because if I take the absolute value of something, I'm always going to get a positive answer. So it is not possible to get x equals a negative number, absolute value of x equals a negative number. And so it will always be no solution, which is nice because that's a quick way for us to finish up a problem. Okay?
Put like 10 numbers on the test.
So with number 5, we're still, before we decide whether we have a positive or a negative, we still have to isolate the absolute value. That's still our nothing changes in our steps here. So I have this plus 10. How am I going to move it to the other side? Subtract it. I'm going to do minus 10, minus 10. So I have absolute value of 3x minus 2 equals 5 minus 10 is what? Negative 5. That negative tells me no solution. And so I just stop.
But on the last,
So let's look at number 6. We're going to isolate the absolute value. So what's my first step going to be for number 6?
subtract 10.
Good. I'm going to subtract 10. 15 minus 10 is 5. Now, how do I get rid of this negative 3?
You added. Divided.
Divide.
Plot twist. Keeping you on your toes.
And I cannot have a negative number equal to my absolute value. So what's my answer? No solution. So it has to be before we split into two equations. It cannot be negative. That doesn't mean our final answers for x can't be negative. But before we split, once we've isolated, we cannot have a negative number there. Okay, number 7, we're going to solve, isolate. So how am I going to isolate? What do I do first? Subtract what?
15.
Subtract 15. So I have absolute value of x plus 2 equals what? 0. That is okay. I would write it down. That's okay.
You just keep on, wait.
Yep. It just can't be negative, but it's allowed to be 0.
But how do you make that?
So with it being 0, there is no positive or negative 0. So we just have one equation that's x plus 2 equals 0. And then we just solve. So subtract 2, x equals negative 2.
And you don't change it to like have another